So we can start. Why it was on a Ruby? Uh, when we use Ruby, we can achieve a good control of our dependencies in application layer. In this case, we can implement a lot of different Ruby applications in a big system with directly implemented scalability. So with a lot of, if you see on this picture, a lot of Rubies you can implement in a big stone of Ruby. And it's a main principle of Ruby application. So when we collect specific Rubies and implement directly in our application, we can create something special. And it's a base, this principle implemented directly by Matsumoto from the start of Ruby language. And it's a main principle of Rails framework, so it's the principles of David Henneman. In this case, when we talk about scalability, Ruby, it's one of the, I think, interesting choices to create something and to manage something, to maintain, because Ruby in the core have a lot of different control mechanisms, how we can control dependencies and other things in our application or service. It's not a problem to understand how it works. But in this presentation, I will show you how it will be and how you can use these mechanisms. So on the first, imagine please that you are a bird in the world of Ruby, and you will collect a specific rubies in the world of technologies implemented in Ruby and Ruby on Rails. So it's not a talk only about Ruby, but Ruby it's the greatest template for this. When this bird collects a specific stone, this bird will achieve a new technology and new specific opportunity, and you will be a specific bird in the world of Ruby technologies, Ruby implementations, and Ruby principles. So first, it's a cross-platform compatibility, because what we have when we use Ruby principles, we can start our service on every infrastructure we want. For example, we have Windows, we have Linux, we have Solaris implementation, FreeBSD and others, macOS, and we can use this technology on every operational system. Operational system, it's a specific layer for different applications and implementations. And with Ruby on Rails technologies, we can achieve implementations in every infrastructure ecosystem. For example, when we use Linux, we can easily create a specific clustering with the Linux control mechanisms, implementations, principles, and others. So, as we understand on the start, every stone we need to keep dependent of other stones. So, for example, when we choose Windows, for example, for basic administration or Active Directory systems, we can use it directly for this and implement in the virtual infrastructure on AVS or on the private our infrastructure. It not depends, and we can interconnect with the Linux systems with the Ruby application, these two systems, and work in the one time with this. But to implement, for example, specific failover mechanism for our Linux system, we need to use Linux firstly. We can implement specific scalability on a layer of application, and it will be failover on the base of Ruby on Rails framework. So it's a different mechanism, but this big system with a different operational system, with a different technologies on database layer, we can use it similar and in one time without any problem. So it's a big power of layer implementation that we can use mixed technologies in our projects, in our big system services and others. For example, I know that in the Booking.com, for example, they use for Active Directory domain controller, they use Windows, but for the web services, they use Linux with the Nginx implementations. For example, for to control financial flow of the booking, they use SAP on based of Solaris and Windows. SAP is, I think you know, maybe you know something about this big system. It's a big system. It's an ERP. So it's a mix of technologies every time, and we can use it in one infrastructure directly, and we can control it directly. With the Ruby on the top of the system, we can achieve a big flexibility. For example, it's a implementation of different functionality with the control of one web server. It's a implementation with Nginx clustering, for example. So it's one of the layers of scalability which we can use in our infrastructure. So big two challenges when we use Ruby implementations, Ruby services. Big two challenges how we can improve our stability. First challenging, it's a maintaining of application stability, how we can maintain our infrastructure. So first step, it's we need to take care about observation of system, implement of different methodologies, how we can control. For example, maybe you know about ELK systems and other monitoring systems. So it's a first step. When we create something, we need firstly to control something. And this control will be first core of stability of our system. And how we can, and the second challenge, and it will be importance of stability for user experience. So when we control infrastructure, we need to control user activity. It's the second step. It's a logging system. So it's not a one system. When we try to implement monitoring system, it's a one thing. When we need to implement a log system, it's another thing. It's a different way of thinking. It's a different way of systems. So it's a different systems with a different logic, and we need to keep our house in a good condition. To keep this house in a good condition, firstly, we need to control this. And the second step, we need to control what we do in our house. So it's the first two steps in the core of control of our application infrastructure. So how we can control the stability of our infrastructure? So we have in the core of every system, we have a database, early BMS service. In the not at all. It's a RDBMS in the core of a lot of different services, yeah, and we have a lot of implementation of NoSQL systems, yes, but I think on the top of rankings in the world of databases for now, it's RDBMS. It's for example, it's a Postgres of or MySQL systems. And firstly, we need to normalize structure of this implementation. So basic schemes of normalization. I think you know about this from the university, but you need to understand that it's a main principle of stability, of application, of services. It's a main core. If your database is not normalized, you will achieve problems in the future every time. You need to, when you implement something, you need firstly think about normalization schemes. And for now, we have five normal layers of normalization and some specific methodics of normalization. For example, beyond Scott normal form. It's a convention about normalization and scalability. So after this, well, we think about normalization. What's the next steps? Data integrity. Data integrity. Mm, it's a main principle of consistency of data. So we need to keep data with a normal layer of isolation. So if we have some specific node, this node in the core needs to be isolated from other our cores. So we need to decrease dependencies firstly, and we need to manage these processes so we don't need to so atomarity, it's one of the main ACID for every module in our applications and every module in our infrastructure. So on our layers from application layer to physical layer, so we don't have only these three layers, yes, PS, and service. We have a big model OC with the 7 layers of implementation of technologies. And one of the main problems in all systems is the control of dependencies. And data integrity decrease this. So it's a dependency of data from one node of our system to another node. One node, one dependency, one node, one dependency. And with this principle, we can control all our infrastructure. In the real world, not every time happens like this. And we need to implement a lot of different dependencies and manage this. But we need to understand that it's important to decrease to minimal layer this depends. So we need to understand every time when we implement a specific new interconnection, we need to control this interconnection and we need to log activity of this interconnection. Scalability. Scalability, it's a one more interesting moment for fast growing system, for example. When we implement, when we start to develop something, we need to understand how we can refactor this when we achieve a big flow of clients or information. Because when developers start, usually developer thinks not only about functionality. It's not the best idea to work in real world, because in real world every time we can achieve a lot of big challenges with the data, with the normal activity of hackers, intruders, and with the not normal activity of users. We need every time to understand what we will achieve in the future with a big scope of problems. And to decrease these problems, we need to start from scalability. For example, we need to implement a specific replication for log system. No, we don't need to keep logs directly in our system. We need to create a specific replica and work with this. We need to implement failover on the base of Postgres, for example. And with the control mechanism of AVS, we can easily implement this. So AVS, it's an interesting system, how we can improve stability. But we don't see what's happening in the core of AVS. And it's a problem for big companies. For example, to keep your data in secure state, you need to understand all what you will do. And you need all information from services from AVS. But not every time you can get this. And every time you need to think where you will lose. You will lose on the control and you will use AVS, or you will achieve a big control of system with a private infrastructure, with a private cloud system, but it will cost a lot of more money and time. Maintains and evolution. It's one more step. So when we implement something, we need to maintain this. When we use a specific cloud system, so when we use specific cloud system, we need to implement the orchestration. So it will be Kubernetes or implementation like Kubernetes. For example, it's OpenShift. OpenShift is a product, some kind of it's a Kubernetes in the core, but it's a big it's a big library with a lot of utilities to easily control Kubernetes implementations. When you use Kubernetes directly, it will be a big work with the scripts, with a lot of different uh, specific moments from Kubernetes. Terraform, templates, Ansible, as other things. So you will achieve a lot of hands work. But OpenShift, when you will use, it's a third party product. It's a big cost product, but you will achieve a big infrastructure with one in time a lot of implemented different utilities, and it will be very fast to implement something like this. But it's a every time we can talk about money. So it's a big cost of money with the Kubernetes. You don't need to pay nothing, but it will be a big challenge for you. Every time you need to think about this. Consolidated scheme. So you need to, one moment about evolution. Evolution, it's a one of the principles, it's a main principle of architecture in a big system. When you create something, you need to think about for 2 steps in the future every time. So not only one, or you don't need only to achieve your goals and that's all. You need to think about 2 steps in the future every time, and and this principle will keep you from the big damages in the future, because every time when you think about the moment, you will achieve your functionality, but on the next day you will achieve new challenges, and it happens that you will need to refactor all your product in a one day, and it's not a good idea, I think. So you need to be in the 2 steps in the future every day. It's a main principle of implementation of systems. So consolidated scheme, normalization of not only of data in the database, normalization of all schema you use in your application. For example, if you see that you have a lot of flow on the client side, you need to implement Sidekick with the Redis, for example, is on the Rails infrastructure. If you have a lot of messages from the different system, you need to implement Kafka or Rabbit. It depends on the flow of these messages. You need every time to understand to you what you will need in the future, and you need to implement these technologies in the past to use in the future. This you every time need to think on the 2 steps in the future every time. It's a base, and you need to reduce complexity. What is this complexity? Complexity, it's in the processes of evolution of system. Every time you need to implement something new, and you need to decrease something old. And to decrease something old, you when you implement something, you need to understand that every module implemented by you in the system, in a one time, you need to disable this or upgrade this. And you need to think about these 2 processes, how you can disable this and how you can upgrade this. It's a one of it's a 2 things from the core of architectural work in every project. So about Ruby, In Ruby, to work with the dependencies, we have a specific package manager gem, and it will be of methodic of control of dependencies in a Ruby infrastructure. And with this manager, we can achieve a big stability. So if you know Ruby, I think for now Ruby works with the dependencies. I think it's a best system to work with the dependencies in a world of web languages, because it was main principle of Matsumoto, integrity. Every time when you implement something, you will implement it with control of gem. And gem can help you to implement, to upgrade, and to disable specific module. And every time you can insert something, delete something, or upgrade something with the help of this. And for now, we have a lot of different package managers in Ruby, but Gem it's the oldest, and I think it's a mm, for now it's a first line of flexibility in this world. But we have dependencies not only on a layer of gems in Ruby. We have a lot of dependencies on Rails layer, but on the layers layer, it's a different speech. It's about a lot of different technologies used by David Henneman. It's another principles, and it's not for today presentation. So how we can normalize and control our dependencies. First step is the documentation. We have a lot of different automatic documenting systems. For example, it's a doc, it's a yard, it's a lot of different standalone third-party utilities. With these third-party utilities, you can create automatic documentation on your system, and you can use it, and you need to think about this every time. So uh, we have two specific big platforms to implement to keep your documentation directly in the clouds. For example, it's a Ruby doc and GitHub pages. So it's a two services for documentation of Ruby projects. Not only Ruby, if you see GitHub, but I think rubydoc.info it's a best service for Ruby documentation. With this service, you can easily in one day transmit your service to another developer, and it's not it for you. It's not will be big problem. So it will be a normal transmission without any questions if you every day keep your mind in these processes. Semantic versioning, it's a one more step. It's a it's a work of our gem package manager. So every time when you implement something, gem package manager creates a specific tree, gem file log. You know about this, I think. And with this gem file log, gem package manager control your dependencies, and it will be every time something new, but with mm, with this gem file log, you will achieve stability of your application. You need to keep this. With the gem package manager, you can not only manage this, you can implement new technologies, for example, and you can improve Ruby versions. Improving, so when you try to upgrade Ruby version from one major release to another major release, you will achieve a lot of deprecations, for example. With this gem package manager, you can decrease this, you can work with this, you don't need to spend a lot of time with fixing of specific technologies in the core of your application. It will be much more easy to do this if you keep principles of GEM. I will discuss this on the next slides. Semantic versioning, dependency locking, dependency caching, and security scanning. It's a four principles to simplify dependency resolution. If you keep these four principles, you will achieve a pure application without problems. I think security scanning for now, it's one of the biggest challenges in the world. And when you use something on Ruby and Rails technologies, you need to implement a specific breakman gem. And maybe you will implement this in the CI, maybe not. But breakman can help you to check and catch specific vulnerabilities automatically. So, for example, CSRF vulnerabilities, it's I think it's the best choice for now to implement Breakman and to keep this when you implement a new feature, you need to strictly check it with a Breakman. I think it will be a good idea for every feature in every project based on Ruby or on the Rails. So, conflicts. Reducing conflicts and vulnerabilities. Semantic versioning, gem file logs, bundle audit, and dependency update. So it's a basics. I think you know about this. So every day you work with these mechanisms, but on the production systems, it's not so easy to upgrade specific gem because it will be downtime on the production system. And every time when you implement a specific gem, you need to think about this. To decrease downtime on the production system, we can implement scalability and clustering. So it will be one more step what we can catch from this scalability and clustering technologies. For example, we can create two nodes on a layer of our web server engines and create specific engines cluster. And with this engine cluster, every time in the one time, we can start two different nodes of our application. And when we disable one of this node, another node will work normally and stable, and the users don't lose functionality and don't achieve. With a bundle audit, for example, for specific new release, you can achieve normalization of your gems. I think it will be good to implement it in a CI/CD pipeline. If you don't have this, I think it will be a good idea to implement this. So, and dependency updates on the production system. It's a big pain of every application because every day we achieve new versions of gems. And when we start to update something on the production system, we can achieve downtimes. We don't like downtimes, and for to decrease these downtimes, we need to implement, for example, load balancing on the base of our web server or load balancing on a database layer. With the AVS, we have a specific mechanism, specific utilities, how we can implement this. On the Postgres server in our private infrastructure, it will be directly load balancing with the replication of our full transaction log on the Postgres system. That's all. So, and we need to keep in a touch that we can achieve some outdated modules. Modules are not living without time. Every day we need to keep this in touch, and this bundle outdated will help us to understand what we will achieve in the future, or this moment we can catch a specific outdated module and we can work with this and we can fix this. We need to keep this every day in touch. So about vulnerabilities, you'll know CSRF, session management, secure configuration, security scanning. Based of the to understand what we will do, how to scan this, I think Brakeman is a good idea. But Brakeman it's not a one idea for this. We have a lot of different standalone utilities to understand what we will achieve. For example, it's the Sonar Cube. If you know about this, maybe maybe you know about this. How you work with
Yeah,
Sonar
yeah,
Cube
yeah.
or some kind of these systems?
I haven't worked with Sonar, but I've heard of it at least.
What? One moment. One more time.
Yeah, I haven't worked with Sonar, but I've heard of it.
Oh, in Sonar Cube, it's I think one of the bestest security scanners for now, and it's free. I think it's a good idea to use for all projects. Uh, Not every time it's truly vulnerabilities. It can be and conflicts directly in the infrastructure, in the architecture of application. But if you want to improve stability and security of your application, Sonar Cube with Brakeman, I think it will be a good idea to improve security of your application. So so one more time. You see my screen? Normal?
Yeah, yeah, we can say it.
Okay. Security scanners, CSRF and CP. Uh, in the logic of Rails, with a CSRF protection, you know that you need to keep params. So and normalization of links. It's a base principle of Ruby. So it's not it's a decreasing of SQL injection. It's one of the biggest problems every time. When we use some kind of web service, we need to think about SQL injection. SQL injection, it's I think the biggest problems in the web, biggest problem in the world of web application. On Ruby and Rails, it controlled by Rails infrastructure with pure links, and not only pure links, but to decrease this activity in the big systems, in the big teams, you need to use a specific automatic utilities. Brakeman as gem and SonarCube as standalone utility. And I think it's in a 99% of systems, you will achieve a stable and normal system after the checking of these utilities. So for now, we can start with normal layer clustering. What is this? We have three principles of clustering: load balancing, replication, and sharding. What it means? Load balancing at when we have two nodes and we can uh, flexible manage flow between these two nodes in one moment. So one request from our client will be managed by one node and another request will be managed by other node. It can be controlled on a layer of web server engines, for example. It can be managed on a layer of RDBMS systems on, for example, on a Postgres. It's a load balancing on a database layer. It can be load balancing on the web server layer. It can be load balancing on the application layer directly implemented in the Rails application. So load balancing, it's not about only one layer. It's a main principle of stability of applications. Replication. Replication, it's another way. So we can work with a log system on a one replicated system and with the basic business information on another system. For example, on the different nodes of RDBMS system, or on a different virtual servers, or on a different virtual environments in the AVS. It's not dependent. We need to every time keep in touch that the main part of our application is the business part, and we have a specific maintenance part, for example, logs, monitoring systems, and for example, support part of our system. And sharding. Sharding, it's a one more principle when we keep our system distributed on a lot of nodes, but a lot of nodes work as a one node. For example, it will be on the next slides, it will be about SEP, and it's some kind of sharing file system. Why we need this clustering and sharing principles? Because for now in the world, it's a hype of artificial intelligence. A lot of machine learning systems. For example, we have Llama machine, Llama engine, and what it means. We have a specific basic model with a lot of information. For example, my friend created a specific model with public transport of Warsaw, and this model you can implement in a Llama, and with Llama you can achieve a specific analysis about how you can, in the best way, to transmit your person from one point of Warsaw to another point of Warsaw. But you need to create this model. Creation of this model is another way. It's a big work, but it's only for one time, and you need to keep this model updated every time. It's another thing. But in the Ruby we have a specific gem, Rumale. With this gem, we can implement a specific rules, and we can with these specific rules implement a specific logic. For example, we need information about how we can. So it's not a one person; it's a 20 person, and this scope of persons want to achieve from one point of Warsaw to another point of Warsaw, or you have. Two persons with the two cats, and it will be another way of traveling in a Warsaw. Every time you need to keep in touch your system, what you will do, and you will in a short time you will achieve answers. And Rumalea, it's a big mechanism for this. Gem parallel, it's a specific gem for implementation of parallelism principle in Ruby. Why we need this? Because we can achieve a lot of requests, and with this gem we can use Ruma lanes with parallel, and it will be a normal online system for for millions requests in the second, but it will be stable and normal. So, but it's a one small thing. It's only for Rumalea, and it's only for artificial intelligence system, because it's a specific interconnection of these two gems. So you cannot use parallel without Rumalea. It's directly implemented for machine learning, and that's all. Because in Ruby we have a specific problem. No, it's not a problem. It's a main principle. Ruby have threads, but basically in Ruby we have a specific one main thread with a specific asynchronous control system, and we need every time to understand this. Ruby, it's a flexible technology for developers, but it's not a low-level technology from the S Rust or C or C++ or Go. It's a different systems because it's for the web development and flexibility of web developer. But these systems, it's a flexibility for the maintenance of big system on a low layer. Yes, that's all. And a small talk about clustering tool. Clustering tools, it's a it's a big world of control tools for clustering or not clustering system, because when you do something, you need to understand what you will need on the finish. On the finish of web applications, uh, mostly you need load balancing performance and stability. It's a one thing. When you use a specific system for data collection, the main part will be stability. When you use when you think about user activity, the main part will be performance. Performance, because users don't like to wait. It's a main principle of every application, and Kubernetes can help us to create can help to automate these processes. How can we automate this? So it's a uh, big fight with the houses in the infrastructure. So with the Kubernetes, we can orchestrate our infrastructure on a layer with Docker containers. Docker container is a it's a only copy of our main core. For example, of core of Linux. With this one copy, we can implement a lot of different environments. So one core, a lot of environments, and we can keep our resources, because when we create a specific virtual machine, we create a specific core, specific environment, specific a lot of different utilities, and we copy every time. When we create the 10 virtual machines, we create a 10 cores of Linux, for example, on the start, and a lot of different environments. But we can keep one core and a lot of environments, and we can control flow of our applications directly in with the Puma. Puma it's a sublayer of our web server to interconnect with our Ruby application. So through the Puma, you can directly work with this. That's all. I think with the Docker, it's a good idea to use Docker, but you need every time to understand what you will do, because Docker container, it's not fully controlled by you, and you will achieve a lot of different interesting situations with the upgrades. You need to understand this, and it's a challenge when you start to implement directly on the bare metal. You can work without these Kubernetes Docker implementations, or you start to use Kubernetes, and it will be a big challenge with the DevOps logic and DevOps work. Every time you need to keep in touch what it will be. If you have a small project, I think it's not a good idea. If you have a big project without these technologies, you cannot work. You need to understand this, and you need every time to think about this. Because to implement specific clustering technologies, you don't need Kubernetes and Docker. You need to think about layers of encapsulation of your system, firstly. After this, you need to implement a specific automatic system as Kubernetes. Because Kubernetes, it will be upper cost for your product. Every time you need to understand what you will lose, or money or honey. SEP. SEP, it's a low level clustering on the file system layer. Why I chose SEP here? Because Ruby have a specific gem, SEP Ruby, and you can directly connect to SEP storage. SEP storage, it's a it's not a replicated storage. It's a big sharding. It's a big sharding with a specific algorithm. But this principle not only used in the SEP. SEP, it's a proprietary product, third-party proprietary product, and it's a stable system. I think, for data collection in the world for now. But we can use RazorFS, a lot of different file systems with open source principles. But we need to understand what we will achieve and what we will what lose. So with a SAP, you will achieve a big storage with a big control, but you will need to implement a lot of nodes only for control, for logs, for mm, for backups, for example. So when we implement scalability, when we implement specific clustering, we every time lose money for nothing. So it will be decrease of future damages only, but it's not a 100% that we can achieve this. So every time it's a ambiguity. Every time we talk about ambiguity. So we need to keep this in touch because it's one of the cases of of a marketplace in the world. What we will achieve, or money or stability. So I have some interesting experience with the clustering. It's a real world cluster in the Phoenix University in the USA, based on Ruby. And this cluster work with specific science reports. So it's not a usual cluster as usual scientific clusters. Usual scientific clusters, it's a system, for example, for calculating of data. But it's this cluster is for preparation of data for for much more bigger cluster systems. But it's based on the Ruby. It's one of the biggest clusters. I think it's the biggest cluster on the Ruby in the world. And I think this cluster worked about 10 years in the same architecture. And you see performance. It's a big system. And the Ruby chosen here because it's a very flexible technology to work with the strings. And it's very easy to implement new nodes in this infrastructure. When you use, for example, Python application, it will be much more longer to implement a new node with a specific implementations. With the dependency isolation of Ruby infrastructure, you will achieve a flexibility and stability and simplify implementation of new node. It's every time interesting. So it's a power of Ruby: control of dependencies, flexibility, and developers friendly. So it's three big parts of Ruby base principles. And with this, you can achieve a huge results. You can keep your system controlled, you can keep your system stable, you can keep your system scalable, and that's all. So for all systems, if you keep these three principles, you will achieve a normal system for a lot of years in the future. Every time you need to keep in touch this. So what I can summarize this best practice, it's a clean your game file, check your scalability, and keep your dependencies. Dependencies, it's I think is the main part of this because you need to understand every time when you implement something, you implement not only functionality, you implement bugs, you implement security vulnerabilities, you implement something which can damage your code. And I think only a half of processes is development. A half of processes, it's security checking, implementation of specific control systems, monitoring system, other things. So every time when you implement something, you need to think about this big principles, and every time you will achieve a good product on the end if you keep this. It's one of the main steps in the development world. You need to keep your project controlled. You need to keep your when you keep this project controlled, you will achieve a stable project. And that's all. Recap. What I can say in the end. So a lot of logic, a lot of different technologies, and I think it's not interesting for all, but main principles, it's the only start. And in the next steps, I will create a big block of new information about this, and it will be much more interesting for you because it will be real world implementation, for example, bullet train and the mechanisms of bullet train optimizations. One more thing, it will be directly about AI implementations with specific practice, how we can use this. But without main principles, we cannot create this. So these presentations were created directly to keep your vision in deep principles of infrastructure implementation, platforms implementation, and services implementation. And we need to keep every time this Ruby principle with a big integrity. You see, when you create something, you need to directly implement something without any damage for modules in this infrastructure. And for now, this work, it's on the side of a Ruby Gems system. You know this, it's a mechanism for our gem update. If you know, yeah, I think a big part of our team know about this. So it's every time based on the technology, but main principles we need to keep in touch every day, every time, and you will achieve a good results. That's all. So if you have some questions, please ask. I'm ready to answer.
Thank you, Sergey, for the very nice introduction to this topic. Yeah, all these clips are for you. We are a bit ahead of our schedule, so please, guys, if you have any questions, just hurry up for a little bit. Yeah, because our presentation should have been ended like 5 minutes ago or something, and just personally, I need to go to another meeting. So yeah, let's do it quickly if you have any questions. One, two, three. Okay, I think that everyone just a little bit tired, probably, and we can always continue this topic and other topics on our chats in Slack, for example, in the dev channel. So, Sergey, you can share your presentation somewhere in the chats, and if there is a question, we can continue discussing this in the threads. Yeah, thank you anyone who joined today. Thank you, Sergey, and have a nice day and a week ahead.
So
Yeah,
presentation share it in the dev channel in the Slack. If you have some specific questions about this, or you need some more information about technology, so please, I'm open to discuss this.
great. That's great. Okay, let's call it a meetup for today. Thank you once again, and goodbye.
Goodbye.
Thank you. Bye.
Thank you. Bye bye. Thank you. Bye.